Good afternoon, everybody. Well, welcome to the Friday afternoon showcase information. Today we're going to be joined by Simon Emery from Xantaro Service Integration, who is going to do the introduction, followed by David Whittaker. And I'll take no more time and hand straight over to Simon, who will introduce this afternoon's seminar.
Thank you, Ian. Hopefully you can hear me all, and thank you for joining us this afternoon. So yes, as Ian says, my name's Simon Emery. I'm Account Director at Xantaro. We're a service integration company. We work very closely with our customers, be they service providers, major enterprises, or research companies, in helping them get the best out of their networks and design their networks for the future. We've had the pleasure in working with GÉANT over the last 18 months on a number of areas and bringing expertise to the table right the way from the optical transmission layer right the way through the IP layer and up into the application layer as well. So the purpose of this call is really to bring you up to speed with a very positive partnership we have in place with Corsa. Corsa Technologies and their Open Programmable SDN switching platform may well be known to you already, having been deployed within the GÉANT network. And we are now in a position where we are able to bring this technology out to the NREN community. So we'd like to spend a little bit of time with you, and I'll pass over to Dave Whittaker in the moment from Corsa in giving you more detail around the Corsa platform and how it may benefit your network. Just before I do that, I'd like to mention to you that we are going to be at TNC next week in Linz. We're going to be there in our own capacity and in partnership with Corsa with a particular aim of evangelizing the technology, speaking about the technology, and helping you to understand how it could benefit your network. So that's all from me. Hopefully that set the scene, and I'll now hand over to David to take you through the offering.
Thank you, Simon. I appreciate that. Good afternoon, everyone. My name is David Whittaker. I'm with the product management team at Corsa Technology. And as Simon mentioned, I just wanted to give you an overview of Open Programmable Networking and virtualizing network infrastructure. As part of that, you'll be introduced to the DP2000 product family from Corsa. But just prior to that, I'd just like to touch on a couple of points about Corsa Technology. For those that don't know, we're headquartered out of Ottawa, Ontario, Canada. We've been delivering hardware to the SDN market since 2014. We have a great relationship with the NREN space, something we're very proud of. And certainly next week at TNC, as Simon mentioned, is another opportunity to certainly bolster those relationships. So we're looking forward to that. So let's just jump right in. And I think the first slide is important just to make you familiar with the DP2000 family. There's 3 variants within the family. They're all shown here. And just to start this conversation, it's important to note that all of the features of the device that we'll talk about today, the virtualization, software-based features, are all consistent across these variants. The real difference between them is actually the faceplates. So the speeds and feeds, if you will, of the devices and the bandwidth and capacity is what differs. So this is a family of products that will grow with you in terms of your bandwidth and throughput requirements, but will remain consistent from a functional standpoint as you move higher and higher into the product families from the 2100 up through the 2400. So just to touch on each of them, starting at the bottom of the slide with the 2100, the 2100 is really about providing the 1 and 10 gig interfaces and throughput that are common in the NREN space today, but providing that flexibility at the best economics. The 2200 addresses the 100 gig need that we all know is present and growing in the NREN space. That's introduced through QSFP 28 form factors that are on that faceplate. And finally, at the top, the 2400 platform, you'll see the difference in the faceplate are two integrated optical ports just on the right side of the diagram. And those allow interconnect between DP 2400 devices and allow for stacking. So this is really your path to production scale when that time is right for you and as your bandwidth needs grow. So with that, I just wanted to touch on the stacking side and just show you how that's done. This is our ability to scale up into the terabit range. The boxes are connected together through the stacking ports that I mentioned and provide that true single management entity, but of course, getting you up into that multi-terabit scale. So a bit about what's under the hood, what the architecture is based on, what was in the heads of our designers when this product was built. And one of the key features of the 2000 series is its ability to be virtualized. So what I've depicted here is what I like to call a hardware resource pool. So as we virtualize this box, this hardware resource pool is in fact set out. So if you were to create a slice, or what we call a virtual forwarding context, or VFC, each of these resources that you see, packet processing units, TCAM, DDR3 memory for processing and performing search, these resources are allocated to those virtual contexts that you programmatically can create. But regardless of how many VFCs you are programmatically creating, how dynamically they're being done, whether they're being turned up for small periods of time and removed after some small period of time, the performance is consistent. So as we allocate these resources, they are protected. So if you had VFCs that were scavenging for resources based on their application, those are all isolated and protected resources dedicated to your VFCs. So it's a unique architecture that had virtualization in mind, that had flexibility in mind, and of course is programmable in many ways, as you'll find out. So if we just look at a simple example of how the box can be used, if you imagine a single piece of hardware, such as what I've put here on the slide, the DP2400, and we just let that fade away into the background and think about virtualizing it, the first thing that a network administrator, the owner of the equipment, the person who manages the box, will want to consider is how we deliver traffic to a virtual forwarding context or a virtual slice of the hardware. So things such as logical port definition within that virtual forwarding context, how much bandwidth we're allowing into those virtual forwarding contexts, and even the encapsulation types of how we're identifying traffic, whether it is 802.1q or VLANs, whether it is an MPLS-based network that the box is sitting in, or other encapsulation techniques. This is the first step. The second being the creation of, in this slide, what I'm referring to as a service type. And those services are delivered through the creation of virtual forwarding contexts. So as the slide shows, I've shown 3 being created. Of course, they're programmatically created through our REST API or our CLI. Each of them being an isolated instance or virtual instance of the hardware, all on one piece of hardware, all operating at line rate in hardware. So there's no software offload. All of this is being done through virtualized hardware resources. The third step is, of course, to allow the management of each of these pieces independently. So as we saw from the top, these applications dropping down, allowing one of two ways to manage those things. So if you were a network administrator, you could, of course, use your own applications to come down and independently control these, both virtualizing both the data plane, as we've discussed, or the VFCs, but also the management paths into this DP2000 are also isolated and contained through network namespaces. So this is an important note that you are truly making these VFCs appear to the application as an independent piece of hardware. Alternatively, for instance, in the case of GÉANT, who has something called a global testbed service, you can allow external guest users, if you will, to come in, bring their own apps to the table, bring their own frameworks, and directly connect to virtual forwarding contexts within the DP2000. So powerful from both the network administrator's point of view and also the user's point of view, because we're able to control the delineation between the network administrator's domain, those who control and provision the box, and the user's domain, those who control a single virtual forwarding context through OpenFlow. So just to dive in a little deeper into the virtual forwarding context that we've talked about. This is a similar diagram to the previous slide. It's showing SDN, an OpenFlow SDN application that may be doing more advanced networking experiments or networking applications. The L3 routing app is another example. It could be Quagga, or it could be FRR, or it could be some other virtualized routing application in this example. Each of those can run independently and manage a virtual forwarding context using OpenFlow 1.3+. But the important thing to note is that while there can be, of course, multiple virtual forwarding contexts on a single piece of Corsa hardware, each of those virtual forwarding contexts can be doing a different application. So whether it's for advanced networking and experimentation, you have a very generic multi-table, wide match, long list of action type pipeline that's available programmatically on this box. Or if you're thinking more, as an example, from a routing perspective, there are optimized, purpose-built pipelines that you can programmatically create and place into a VFC that perform an L3 VPN function. So some of those features that you would find in there are, of course, IPv4, IPv6 FIBs that can scale and contain the entire internet routing table. There are VFCs that you can create which will do more specific applications, for instance, L2 MAC learning switching, point-to-point circuits, VPWS type functionality. All of these different functions, when contained in a VFC, can run together completely isolated from one another on the platform. So that's just to give you the idea of the breadth of the different type of forwarding that these contexts can provide. And just moving towards the bottom of this slide are what we call logical interfaces. And as discussed earlier, that allows you to identify the specific traffic or sub-interfaces of your physical ports that you would like to bring up into those VFCs. So instead of thinking of this as a rigid port, physical port mapping up to a VFC, you can instead identify, perhaps in this diagram as shown, with VLANs, you can place those into a specific VFC. So now you have multi-tenancy on a port. So a single port can accept and direct traffic to perhaps a layer 2 service, or even perhaps a layer 3 service at the same physical port. Something, of course, that GÉANT is doing with their SDX, their Open Exchange. So the last point I wanted to make on this slide that we haven't discussed yet is, as per other switches in the market and other devices in the market, Corsa offers an extensive QoS function. And that QoS function is centered around the logical interfaces that I just described. For instance, you can do metering at the ingress of these logical interfaces, controlling the rate at which traffic arrives at a particular open flow port at a particular VFC. You can also do shaping. So we are allowing for queuing as traffic egresses the VFCs out towards the physical port and into the underlay or physical network that the device is sitting in. And of course, the shaping, we are queuing to perform that shaping, and do have congestion management functions in there, such as WRED, to control that. So there is significant traffic management tools that come into play with the virtualization that really allow you to get really great control of the traffic as it enters one or more VFCs on the device. Again, to be clear, all of this is programmatic through a REST API, and I'll be able to show you just a quick demo of some of that programming and how quick and easy it is at the end of these next few slides. So just to highlight some of the things we've talked about, when we speak about open programmable interfaces, there's really many layers to that. And I think this is a source of a lot of questions that come to Corsa. How can I provision? At what layer can I talk to devices in the SDN space? And so this is just a layering example of the multiple levels in which you can engage a Corsa device. Of course, at the top being the network application, I've listed a few here, very common to the NREN space, and GÉANT in particular. You can have bandwidth on demand, circuit switching, software-defined exchanges and routing functions, all in a prepackaged controller. So that is one way to go down and talk to a Corsa device. The next level below that is more of a functional layer. So that is, how do those applications go down and speak to those? And those are often delivered through ecosystems or frameworks. In this case, I've listed a few here. Of course, one that I think a lot of people in the NREN space are familiar with is the ON Labs ONOS flow objective functions. There's, of course, the model-driven service abstraction layer in Open Daylight. There's the RIU framework. And of course, we also have Corsa REST APIs to do that type of functional layer, where instead of there being definitive open flow calls, we're at a much higher abstracted layer. And lastly, as we get closer towards the bottom, we do have our native interfaces, which are, of course, OpenFlow, our CLI, and our Corsa REST APIs to program the device itself. So this was just to speak to the many layers that you can come in and engage a Corsa device, program it, and use it in many useful ways. So we feel we've got all the layers covered. That there's many ways to come in and take advantage of the virtualization and of the programmability of our box. So this was a very quick talk about the device itself, its functions, what it's offering are. But I just wanted to also touch on some of the things going on at GÉANT with the DP2000 family. So our devices are deployed in many POPs around Europe within the GÉANT network. The boxes specifically are in use by the joint research activity groups, the JRA group and service assurance teams within GÉANT. In particular, there are services that are in pilot deployment right now. In particular, those are the GÉANT SDN BOD for bandwidth on demand application, the software-defined internet exchange point, and as I mentioned earlier, the global testbed service. And not to get into too many details, but I did want to show you just some of the features of our box that are in use by these pilot deployments within GÉANT. So if we consider the bandwidth on demand, it is actually an application within ONOS used to control a network of Corsa 2000 devices. So some of the key features in use by BOD is topology discovery. That's using discovery protocols like LLDP and BDDP. And that's how that is used in the device side of things is it boils right down to packet in, packet out messages in OpenFlow. L2 circuit creation using OpenFlow, which includes pushing and popping for encapsulation purposes, rate limiting using OpenFlow meters, and monitoring of the bandwidth, pardon me, using packet and byte statistics that are available in OpenFlow. And these common features continue down here, but I wanted to call out some continual differentiators as we go through. In the case of the GÉANT XDX deployment, there are layer 2 and layer 3 applications that exist within ONOS, again, that are used to automate connections between different network access interfaces. So in this case, we're using VFCs to separate the multiple L2 or L3 applications to perform those different types of connections. There's independent SDN control of each VFC. Each of the services are available through multi-tenancy at a single port using our virtualization techniques, something I mentioned in our earlier slides. And of course, we provide that IPv4, IPv6 internet scale routing FIB, which is key to the L3 portion of this deployment. And last but not least is the global testbed service. Simply put, it delivers virtual environments as testbeds, not just networking, but also compute and storage, as some of you know. But some of the key features here, when we're allowing external experimenters or folks from the NRAN communities to come down and use these devices, it's key to isolate their management side as well. So in-band management interfaces are called out here, distinct management LANs using network namespaces, ability to virtualize hardware at 10 gig and 100 gig. That'll be key to the global testbed service, and to continue to independently control and isolate VFCs. So this was just a touch on some of the deployments within GÉANT. Ian, if you wouldn't mind, I'd just like to take the last moment just to show a quick little demonstration of using ONOS. So this demonstration will just very quickly show you. There it is. Thank you, Ian. It'll very quickly show you the turnup of several VFCs on a single Corsa device using ONOS. And some of the common features that I'm using with ONOS here are topology discovery. So you'll see me right now use a REST API, and this is just a Postman typical REST client. You'll see me do in this scenario, we're going to add some VFCs, we're going to add tunnels, add controllers. These are all the steps that one would take programmatically to create VFCs, tie them to your underlay network, and eventually add OpenFlow flows into the VFC. So I'm going to start this run, and you'll see just how quickly ONOS discovers, in this case, 3 distinct VFCs. Now, ONOS is unaware that these VFCs are being hosted by a single Corsa device and that they're all independently controlled. So when I come down, I'm going to actually, now that it's discovered the links between them through topology, I'm just going to run a quick ARP function using my Spirent test center, which will allow our hosts to be discovered. So there are ARP rules that have been provisioned into the VFCs for that purpose. And you'll see the ARP proxy tools within ONOS function here and discover those hosts. The bandwidth numbers that are coming out is an ONOS function that's being pulled through OpenFlow statistics, both packet and byte counts. You'll also notice in the top right that after this, ONOS is now seeing 17 flows, it's seeing additional hosts, and that's all part of that discovery. So the last step is we'd like to tear down this setup. So perhaps for some window of time or in the global testbed service an experimenter was using this topology, the administrator of the DP2000 can very quickly go in and delete this setup. And that's as simple as going in and deleting these bridges. And you'll see this be done through the REST API. It happens very quickly, at tens or hundreds of milliseconds. And when that's done, the VFCs disappear and ONOS is no longer communicating to the data paths IDs within OpenFlow. So this was, again, a very quick example discussion on the DP2000, virtualizing it, using that in new ways in your network. As Simon mentioned, we will be at TNC. We'd love to talk about your use case. So please, we'd welcome you to come to booth 16 at TNC and come have a chat with us, see if we can do some collaborating. Thank you, Ian.
Okay, that's fantastic. Thank you, David and Simon. Quick, if anybody has questions, please use the chat box on the right-hand side. Both David and Simon are keen to answer your questions. They're also keen to see you at TNC next week. So please feel free to type your questions in the right-hand chat box, and we'll see what anybody's got to say. Can you see that one, David or Simon? Slide 8 underlay, exactly.
Yeah. Hi, Toby. It's David Whitaker. Thanks for the question. The term underlay is a term that we use. The best way to describe it quickly for the purposes of today is it is the physical network where the box sits. So as compared to what we use the word overlay to describe where the virtual forwarding contexts sit. So that underlay could be MPLS based, it could be 802.1 based or VLAN based, but that's typically how we separate the notion of the underlay network, the physical network that the box is sitting in, from the VFCs, which are of course a logical entity.
People. I kind of get the impression you're going to get bombarded at TNC. So be prepared for some tough ones over there, David and Simon. Anything else you'd like to add, Simon, before we call it a day?
Not really. From my side, just want to say thank you for giving the time up on this afternoon. And as we said, yeah, we look forward to those conversations next week in Linz. Thank you.
It's been a pleasure. It's always useful to get a chance to talk to you guys and get some inputs and some, a little touch of here's a bit of pre-information, here's a bit of additional information, here's something you might not have known. I'm sure our people are always keen to tap into what you've done. So there's a lot of thank yous coming from people. It'll be great to see you in Linz. Thanks for taking the time to do this. Thanks for being part of TNC, and we look forward to your company in the ensuing time, as they say. So I'm going to call it quits now. One or two people in the chat window saying thank you already there. Richard Hughes-Jones, James, Craig, Rick. Excellent. Yeah, it's been a good one. Thank you, David. Thank you, Simon. And we'll sign off.
Thank you. Bye-bye.